a squared times cosine squared. And then, can I take the square root of a squared? Can I take the square root of cosine squared? Yeah. And are you guys with me? Integrating this is rough. Integrating this is not that bad. Integrating a constant times cosine theta is actually really, really easy.
But you don't have theta. Yeah, you do.
Well, how this works out in practice of some questions is going to take us a second. We'll get there. I need you to be a little bit more patient than that. Everybody good? Okay, so depending on how this radical of squares is set up, there's basically three ways we can assign u. U is either going to equal a sine theta, u is going to equal a tangent theta, u is going to equal a secant theta. Okay, so when it's the constant minus the function, we use a sine theta. When it's the constant plus the function, we use a tangent theta. And when it's the function minus the constant, we use a secant theta. We doing okay?
Is there a reason why it's like similar to that? The stuff behind it?
Yes, this is imagine we take this times steroids, where basically it's this on steroids. Yes.
Is there like,
But you're not always gonna have arcsine or arcsecant in your answers for this one because of the way it ends up playing out.
But I mean like the constant plus.
Well, the fact that those are related to essentially the same triangles, yes. Yeah. Go ahead.
Would you, like, I'm sure you're going to show us, like, the mathematical reasoning why, unless that's what we just did. But, or would you recommend, like, just memorizing, like, which goes with which?
What is likely to happen is on a quiz or a test, I will give you this piece.
So just, like, for each adjacent one, or just the first one?
No, I'll give you for each of them.
Oh, okay, perfect.
I won't give you this piece. But that'll make more sense as we work problem. So I'm assuming you guys would like to see a problem with this kind of worked through. Okay. Because I'm a good person. I mean, if you guys are doing good, we don't need to work every example. I'm just...
It's probably for the best.
There's a reason I gave you so many examples. Yeah. And we're doing this today and the block period tomorrow. That being said, part of that block period will be reviewing and finishing out your homework. Your quiz and homework are Thursday. Okay, so you guys, let's look at this first one. We have a square root of x squared minus 49. So we have, all right, so what we're going to do is let u, well, in this case, our function is x. So we're going to say x equals 7 secant theta. Are we feeling good so far? Yeah. Okay, great. And you guys, what would that look like on my triangle if this is theta? Secant is, well, on the triangle, it might make more sense to think of it as secant is hypotenuse over adjacent.
So x is going to be your hypotenuse.
X is the hypotenuse. 7 is your adjacent. And guys, if we use the Pythagorean theorem, what does that make the other side? Huh. Yes.
Why is secant x over 7?
Okay.
Or whatever.
So we have, why is secant x over 7?
Mm-hmm.
Because if I got this, I would divide both sides by 7.
Oh. Well, wait, why is it like, you know that x is the hypotenuse and 7?
Because, okay, so cosine would be 7 over x, yeah? You with me? Cosine is adjacent over hypotenuse.
Okay. Yeah. Okay. Yeah, I see what you're doing.
Is everybody good? Yeah, so it is. It's SOHCAHTOA in terms of how we're assigning things.
So the u equals the variable and the a is the constant.
The u is the function that is being squared. So you're always going to look at the variable is the function, yes. Okay, you guys. Now, if x is equal to secant theta, and we're going to be substituting in, right? I'm sorry. I'm just going to do this. If we substitute theta in, do we want a dx or a d theta?
D theta.
We need to be d theta, right? Because we're going to integrate with respect to theta and then resubstitute back. So how do I get that? I take the derivative. What is the derivative of 7 secant theta?
Secant tangent. 7 secant tangent.
Secant theta, tangent theta, d theta. Are we doing okay? Okay. So now that we've done this, let's do our substitution step. So instead of integrating dx over the square root of x squared minus 49, I'm going to integrate, well, what am I going to replace dx with? 7 secant theta, tan theta, d theta. And then I'm also going to replace the x with 7 secant theta.
Is that a minus?
Yes.
I mean, on the top?
No.
Okay. Sorry.
Is what a minus?
The secant, but the thing between the secant and tangent.
Is that theta?
Is the theta.
They're being multiplied.
Well, I mean, okay.
Okay, next.
We just take everything out of the square root.
We're gonna, so this essentially no, not until we rewrite it. So on top I have 7 secant theta, tan theta, d theta. And on the bottom I have the square root of, I'm gonna call this 49 times secant squared theta minus 1. What is secant squared minus 1? Tangent squared, right? So now I have 7 secant theta, tan theta, d theta over, now I can take that square root and have 7 tangent theta. How are we feeling? Anybody see anything that makes this
Yes.
the 7 and the, so really this has now become, we are integrating the secant of theta d theta, which is way easier to integrate than, does anybody remember the integral of secant?
No, I was actually.
I think it was something I got stuck
Yeah, I know.
On the homework.
Is it like the, is it the square root of tangent?
Well, it's 1 over cosine.
Or do you do
so
that
it would be the.
If we did, it's going to be just as complicated.
The natural log of cosine?
It's not the natural log of cosine, but I like where you're thinking.
Oh, wait, the natural
That was-
log of sine.
No, both of those were for the tangent and cotangent.
Wasn't it the weird thing where we did?
You did the plus and the minus. So it's actually the natural log of the absolute value of secant theta plus tangent theta.
Where would I be able to reference that?
It's in one of our things.
That would be from last semester, like towards the end of last semester.
Okay. From last semester.
I think it was like the second to last unit.
I don't recall this. I don't recall this.
Because we did it for secant and then we did it for cosecant, and it was just like, I think a sign difference. Was
And negative and then cosecant
Yeah,
plus
there was-
cotangent.
it was
Yeah.
cosecant minus cotangent.
We even wrote a proof of it.
Yeah.
I'm sure we did, I just don't remember.
Just
Yeah.
I remember
I need to
the
find
U
where
was just kind of pulled out of nowhere as usual.
What is very likely is tomorrow I will have for you guys some trig identities on one side and some integrals of trig questions. The integrals of some of these on the other. You won't have those on the test, but you'll have them as reference sheets to practice and to study. I'll make you a study guide, basically. Okay, you guys, did I want to integrate this with respect to theta? No, we need to integrate it with respect to x. So the last thing we need to do is go back and change secant theta into a function with respect to x. Well, as we were just saying, secant theta was, okay, plus, what's tangent theta?
The square root of x squared minus 49 over 7. So you use the triangle.
You use, which is why the triangle's there.
Yeah.
Wow.
I'm just gonna go because I know that's what
That's what I remember from last semester.
I remember I like finally figured out the triangle after 7 years.
Cool. All right. Let's do this one. X equals 7 something theta. 7 sine theta. Great. Dx would equal 7 cosine theta d theta. Put it on the triangle. Sine is equal to x over 7, so this would be x, this would be 7, this would be the square root of 49 minus x squared. Me too. I did not do a good job with that. Well, no, because and I'm not going to give you the triangles on the quiz because part of it is you need to recognize when you need to use that versus a different strategy. So if I give you the triangle, you know which strategy to use, and so I can't do that. Maybe I will give you a sheet with triangles on it that is just blank, that is separate. Would that be the nice way to do it?
Because the triangle still like granted I rigged it, but the triangle's kind of taking up space.
Did you say I should give you a thing of cookies?
No. Yeah, that's a good
Yeah,
idea.
yes,
It's
right.
like
If you're willing to.
frosting, and we can like frost our edges. On the triangle.
Oh my God, not happening. So not happening. Okay, you guys, let's do, all right, so let's do our substitution step. On top, we have 7 cosine theta d theta. On the bottom, we have the square root of 49 minus 49 sine squared theta. So are you guys comfortable with this is 7 cosine theta over 7 cosine theta d theta?
I'm gonna take a breath here to
For sure.
catch up.
For sure. There's a lot going on here.
Future me will not be able to follow.
Uh-oh.
Oh.
It's just
Is that one or
It's
zero?
just
Yeah, I know, but how?
That's the integral of 1 d theta, which is
theta.
theta and plus c, yeah? What is theta plus c? Theta is the sine inverse of x over 7 plus c.
Okay.
And by the way, you guys, this one, we could have done, this way.
True.
I never remember those ones.
Neither do I. I have to I draw the triangle for everything. It makes so much more sense to me to draw the triangle.
Could that also be like the inverse cosine of like?
90 pi over 2 minus x over 7. Yeah, but that seems like a much harder way than just saying sine inverse.
Okay. True. But I was just wondering.
You were just wondering, I thought.
What's up?
How do we tell the difference between the sine inverse and the sine to the negative first power? Or are they the same?
It would be they are not the same thing.
I didn't think they were the same thing. I'm just wondering why the notation is like the exact same.
To be annoying, because mathematicians were the worst. It historically comes from the fact that you have 4 or 5 guys that were all doing the same thing, right? And they all use different notations, right? So there's the Newtonian notation, there's the Leibniz. So it's the same way that we could say the derivative is f prime, or we could say the derivative is dy dx. And when you have a bunch of people working on similar problems independently, because it's not like they could just share their work over Zoom, right? So because they worked independently, they worked within the same concepts, but now we have like 15 different notations. So how do you distinguish between something to the negative 1 power and an inverse? The typical thing we do is if something's to the negative 1 power, we write it in the denominator instead of as an inverse. Cool. Do you guys want to try this one on your own?
Yeah.
It's not one of those, yeah. No, it's this one. Isn't it? No, because of the square root. Yeah.
Isn't it like it's not one of the?
What's up?
So we're like expected to know how to integrate secant
Yes,
and
which is just negative and then cosecant plus cotangent.
Oh my god, sorry, I totally remembered this right as you said that. Like I remember writing down those terms.
Wait, what did you say cosecant was?
The integral of cosecant x dx is equal to the negative natural log of cosecant x plus cotangent x. So it's the same pattern, just a negative out front, which is consistent. You guys, when you think about like the derivative of cosecant, the derivative of like the derivative of secant and the derivative of cosecant are the same.
and what was it for cotangent? 1 over the metric.
So that one, so for cotangent, it's I think I actually have to do this each time, right? So then if you let u equal sine x, du equals cosine x dx. So now you're integrating 1 over u du. Natural log of the sine of x. I'll always have to write it out, so I remember, like, whichever one is in the bottom is essentially the one it is. So likewise, the integral of tangent is negative natural log of cosine x, I'm pretty sure. Because, yeah. Are we good? What do you think? One more? So what are we doing here?
That's a good question.
X equals 7 sin theta.
7 sine theta, okay. Dx then would be 7 cosine theta d theta.
Can we just, from the start, write it as 7 minus x?
I'm sorry?
Can we just take the square root right away?
You can't distribute a square root through plus and minus. What are we thinking?
It's just sine.
Hmm?
When you were distributing it, or like doing it, shouldn't have been 49.
We feeling good so far? Cool, now we just have to integrate 49 cosine squared theta d theta.
Wait, 49.
Can't you turn it into the thing with the 2 theta?
Mm-hmm. You use the power reducing formula.
Why is it 49?
7 times 7.
You can pull it out front because it's constant.
Good? Huh? Well, first we got to integrate, and then we'll worry about what theta is.
I see, like the triangle's taking the
You guys were just thanking me for giving you the triangle. And now it's too much space.
I didn't say anything. But
We doing okay?
why did you write a theta with 1/2?
Because in my head, I split this up into 1/2 plus cosine 2 theta.
But you can't, you just write
Yeah,
as
so
one
why'd
half
you write it?
Oh, wait, but it's not.
It's not, no, it's 1 plus,
No, it's 1 plus 2 cosine 2 theta over 2.
so 1/2.
So why'd you write theta?
Wait.
Because the integral of 1/2 with respect to theta is 1/2 theta. Yeah.
Can't you just do your integral of cosine 2 theta?
You can.
You can. I just was, so that would be 1/4, or no, 1/2 cosine, wait,
Yeah, 1/2.
1/2 sine 2 theta. Plus C. This feels like I want to double check my cheat sheet now. Does that feel right? Oh, I wouldn't follow me blindly. By any means, I would not follow me blindly.
I do care a little bit.
There's no 2 here.
There's not.
Yeah, which makes that 1/4.
That is so silly. That wasn't sarcasm. Being serious.
So it's 1/4. I enjoy the
People think
I
I'm being
enjoy
sarcastic
the
right now.
rapport in
I
this
don't need to be
class,
taking
but
this
not
class,
the
but I
math.
am taking it.
We're so proud.
Thank you.
Oh, she's so.
I can't see that.
I already started my answer.
How we doing with sine 2 theta?
And then just, wouldn't it be just be sine to arctangent x
Oh,
over sin?
because that's just what theta is.
Huh? No.
You can take the function of an inverse function.
You can.
You can.
You absolutely can. But that doesn't.
Yeah, all your tea I need. For all the wrong
But,
reasons.
like, that 2 is not being so, like, it has to do with, like, when you're taking the sine of 2 theta, that's not equivalent to 2 sine of theta. So you can't just.
No, I know, the two's in sine.
Can you multiply? So you don't just
Like, it's
multiply
like-
2 to theta?
Wouldn't you just
We don't know what theta is.
Is
Oh,
it-
so you want to call this sine of the sine inverse of 2 sine in.
what I was saying? I don't really know what I was saying, so that's what theta is.
Well, no, the 2 would be multiplied by the sine inverse. Like, I have it as sine parentheses 2 arc sine x over 7.
If you multiply sine and arc sine, do they cancel out?
Well, you don't multiply them. You would take the sine of arc sine.
Yeah. Does it still cancel out? Because, like, I feel like it would.
Like, I feel like it should.
But that makes sense, though. Because
Right,
it's like,
they're inverses.
Or
doing the sine of what the sine is, like.
so hold on. You're doing
Inverse of the sine.
1/4 times the sine of.
Of 2 arc sine
X over 7.
x over 7.
Yes, that's what I have.
What would that be? Can you simplify that?
Yeah.
They ain't right, it's wrong.
I'm not sure if it's wrong, but that's definitely not what I would be looking for.
Then what, how would.
Oh, you guys, the double angle formula for sine 2 theta is equal to 2 sine theta cosine theta.
Oh.
about time to learn the double equal formulas.
You need that paper again, that like orange sheet. It's in my room, I still have it. You put it in this folder.
I understand why my dad feel like, oh, my dad failed this class 6 times.
Actually, I'm asking because I changed the graduation requirements for his paycheck.
Love that for it.
After he was in school for 10 years, trying to pass the class. So. And did you just like,
Continued second.
oh, because the got it. I've dropped a few parentheses throughout.
All right, guys, we'll do the more complex problems tomorrow.
I don't think she's joking.
I'm not joking at all. I'm not joking.